Let's try to do this. A, B, and C are three events, the probabilities. So here we're talking about probabilities, not just the numbers, but probabilities, right? On the events, of three events, we are given the Venn diagram, as you can see, the 10.11. Then they say that if it is given that the probability that at least one of the events will occur is 0.893. So the at least part, this one is the one that is actually not participating. So the at least part is when we add all of these values, then it gives us what? 0.893. So in percentage, probability is from 0 to 100, but in decimals is from 0 to 1. From 0 to 1, meaning whatever that we are given there are probabilities, as they said above there on the statement. I hope it makes sense. So when we add everything inside the events, they must give us 0.893. So they want us to determine the probability of y, meaning we must add everything here and equate it to 0.893. I hope it makes sense because it is at least 1. All right. So this is at least 1. It is equal to the 0.893. Therefore, y equal to 1 minus 0.893. So that we can find the one that is outside. So y will be, let me try to use my calculator. 1 minus 0.893 is 0.16. No, it's 0.11. Sorry, not 16. 0.11. I hope it made sense. Then B, they want us to actually determine, or they're saying X, determine the value of X, the probability that all three events will occur, the center of the centers, right? The center of the centers. We do have the answer of all the events, of everything written in the events, which is 0.893. Then let me just write this one right here, and we do have y, which is 0.11. Therefore, we add everything here, we equate it to 0.893 to find the value of x. So x, okay, let me just write it this way. We can add everything inside the events and x, then we equate it to 0.893. Therefore, 0.893 equal to x plus, let me try to add all of these numbers inside the events. But I hope you're getting this. So it's going to be 0.733. Therefore, you solve for x, then the answer is going to be 0.16. So that's the value of x. That's the intersection of the intersections. We normally say King of Kings, referring to Jesus Christ, as he's the King of all the kings. So 0.16, it is the intersection of the intersections. All right. I hope it made a lot of sense. Okay, I think we can continue. With 10.12. If you don't understand, please make sure you rewind the video. Okay. Determine the probability that at least 2 of the events will take place. At least 2. So when you talk about at least 2, we add all the intersections. But when we talk about at least 1, we add everything inside the events. Probability of at least 2 events equal to, we add these events inside the Venn diagram or inside the events, as we know that these are probabilities, not just the number of learners. We add everything, all the intersections, equal to 0.61. So that's the probability of at least 2 of the events that will take place. So this is for at least 2, as I'm highlighting on the Venn diagram. Then this one is for at least 1. Then this one, the intersections, but not the intersections of the intersections, is only 2 of the events. I hope it makes sense. But do go to that video. All right, 10.13. They're asking a question: that the events B and C independent? Justify your answer. You don't just say yes, you justify your answer by calculation. Okay, so what we're going to do now, we want to get the probability of B, probability of C, and probability of B and C from the Venn diagram. So what is the probability of C? The probability of C, it is the entire circle or the entire event. Let's just write this 0.16 as the value of X. So the entire circle here, or the entire event of C, that's the probability of C. You add those numbers, you're going to get 0.56 as the probability of C. Then the probability of B, you do the same thing. You add all those probabilities inside event B. Then you add them. So they're going to give us, let me try to use my calculator, going to give us 0.643. I hope it makes sense. I think now you have 2 marks. Then what about the probability of their intersection, the intersection of B and C, probability of B and C, or of C and B? Not A, the probability of B and C. This is the intersection of B and C. Is going to be, you multiply these two, they will give you what? 0.36. Then now what you must do, you have to multiply the probability of B and the probability of C. So you can tell that these events are are independent events. We don't have dependent events. So P of B multiplied by P of C equal to 0.643 times 0.56. You're going to give us what is 0.36. Then by that reason, we can say that the probability of B and C, or B and C, are independent events. Therefore, events B and C are independent. Maybe someone will ask, why isn't the intersection of B and C the 0.2? Is because that 0.2 is the intersection of B and C only. Now let's say they wanted you to show or to prove that the probability of A and B are independent. You don't just write this. You don't write this. You only write this only when they want you to calculate the intersection. But if they want you to prove, you multiply what these two to determine the probability of the intersection. Then you compare the answers. I hope it makes sense. So this is how you do this. Very, very important.